The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg, it's the Brothers Wisp. Let's take a ride through space on this mothership. Wireless networking. We talk.
Hey everybody, it's Tommy with the Brothers Wisp. I'm here with Brian
Klaff.
With Ethernity Ethernity Networks? Yeah. And you guys have some pretty cool equipment here and really cool technology.
Yeah. So Ethernity basically makes networking solutions, technology, products for the telecom industry on semiconductor, primarily on FPGAs. I don't know if everybody knows what FPGAs are, but
Programmable gate array.
Exactly.
Everyone's running
reprogrammable hardware, which is great because you can always reprogram it even when it's field deployed. That's what's in the name, and that makes it future-proof, which is pretty cool. And what we're really promoting here at this show is our layer 1 link bonding technology, which we think is ideal for WISPs. A lot of WISPs right now are considering adding E-band to their towers. Most of them have not yet made that move, but a lot of them are considering it. But a lot of them are very concerned about the fact that those 10 gigabit links are especially sensitive to environmental factors. And so they're worried what happens when they put one of those on their tower, and then a cloud comes by and the link is degraded, or it starts to rain and they lose the link entirely. And so we have a solution for that, in that we allow a WISP to create a bonding instance with multiple links. And it is agnostic as to the bit rate of those links, to the frequency or capacity of those links. It is also agnostic as to who the radio vendor is, and even to the protocol itself, so that you can have E-band and microwave as wireless links, but you can also bond a fiber link with those links. So that provides you with an awful lot of flexibility and a lot of fail-safe measures in your network planning.
Yeah, so it's similar to 802.380 link bonding, but unlike those where you need to have exactly the same size, you need to have the same latency for each link, you need to have all these other things need to be exactly the same, and you still don't get all the, what we see all the time, like on the forum, somebody's like, I'm bonding these links together, but I'm not getting the aggregate throughput when I'm speed testing.
That's exactly right. So what happens is that with link aggregation, which is what you're referring to there, that off-the-shelf link aggregation, you can only bond together links of the same exact bit rate, or of the same. Basically, what happens is there's a hashing function that from one port on one side to the other port on the other side, and you're going. It has to be the same types of packets. So therefore,
way we're keeping
you keep only those together.
The traffic that is similar source and destination going across the same.
And not only that, but you're sending full flows when you're doing that. It's basically determining which link it'll go over based on the full flow.
Yep.
And the other problem with link aggregation, a couple other problems with link aggregation, but the one main one is that you don't get to determine where what traffic is going to which link. It's all done based on an even distribution of the traffic to the various links that are in that aggregation. This is a problem when it comes to management traffic, for example. You can't determine where management traffic is going, which radio it's going to get to give it the information that it needs. So you have to define a separate port specifically for management traffic, and you have to therefore handle management out of band. Another issue with lag is, especially when you suddenly lose a link. So you can have an active standby setup where the standby link will now jump into action, but it can take a little while for that to be, tens of milliseconds, let's say, for it to be determined that there's a downed link. Ours will pick it up in less than a millisecond. Not only that, but when you have a degradation of a link aggregation won't notice it at all. And it'll continue sending traffic to that link as if it were at full capacity. And then you're going to start losing data.
Okay.
And with our bonding, we have a proprietary link capacity adaptation algorithm that almost instantaneously will know that there's been a degradation or a lost link, and will make the necessary adjustments so that your traffic will be rerouted across all the other links in the bonding instance to ensure that there's zero data loss. We also, with regard to the management traffic that I mentioned, we allow in-band management because we can bypass the bonding for specifically management traffic. We can have management traffic be identified as such. It will bypass the bonding and use a standalone port within the bonding instance to ensure that the traffic reaches the proper radio to get it the information that it needs. So those are huge advantages that you get. There are other advantages as well. For example, we have a priority-based policy system whereby you can determine in advance how much of the given capacity within a link you want to use within that bonding instance. So you don't have to use the full capacity if you don't want to. You can determine, I only want to use a part of the capacity in this particular link, and save some of it to use in a different bonding instance. This is another advantage.
Okay.
Whether it's in link aggregation, a port must be assigned to a specific link aggregation and cannot be used in multiple lags.
Yeah.
In ours, a port can be used in multiple bonding instances. That allows you to slice your traffic as you see fit, giving you the most possible flexibility. So another thing that's different between lag versus our bonding is that tunneled traffic in a lag, whether it's IPsec or MACsec or any other tunneled traffic, must use a single link. Because all that traffic, all those packets have the same hash.
Yep.
So therefore, they have to go over the same link. In our case, because we're breaking it down into frames and we're not tied to any kind of a hashing function, tunnel traffic can still be distributed over multiple links within the same bonding instance. So you're not going to have an issue if all of a sudden you've got your IPsec traffic or MACsec traffic that's supposed to be going over a specific link within lag, and then all of a sudden there's a reduction in the effective capacity of that link. You got a problem.
Yeah.
But in ours, no problem at all, because we can distribute it across all the links within the bonding instance, and you reorder it back on the other side. No problem.
I mean, these are all huge issues that you have to consider, and one reason why a lot of guys will prefer to do like VLAN stacking and running OSPF, and that's why there's like a lot of layer 3 options, going even higher, which adds a lot of complexity to
That's exactly right. This is a very simple way. Basically, there's not much configuration involved. You set your policies, your priorities within your priority policies, and then once you've set that, you're pretty much good to go. This can be added on top of everything that you've got. It's a simple. Basically, we are offering this within our UEP 2025 box, which is an indoor or outdoor unit, and it can be placed into a base station, and basically it's just your traffic will run from through there. It's perfect for wireless backhaul. It can also be used, because it works with fiber as well, it could theoretically be used for the access network as well. So and it's not overly expensive. I would encourage people to contact us so that we can find out specifically, depending on the features, it changes a little bit here and there, but it can be done with power over Ethernet or with DC, and basically not real expensive, for a single link. You put one.
It can be powered by power over Ethernet.
Yes.
Okay. So about how much wattage is this actually? I mean, it's got to be less than 100 watts.
Oh yeah, for sure.
Very much so.
I'm trying to. I can look it up.
That's fine.
You know what? I'll look it up and give you an answer. But
I'll put it at the bottom, guys. The video. And these guys haven't. I've thrown all sorts of weird, crazy questions at Brian, and it's been really fun because he'll not have it right at hand, because we're talking about how many jumbo frames or something like that, and they've reached back over to their engineering guys, and next day I had an answer, and and all very, very technical language. It's been a lot of fun chatting with you.
Well, it's been great. Thank you very much for having me on this. And if anyone's interested, you can reach us. Our website is www.ethernity.net, ETHERNITYNET.com. And we would be happy to speak to any WISPs that are interested. It really can improve your network performance and provide you with some real necessary redundancy in your network.
Yeah, no, this has been really cool. I wish I'd seen you guys like 3 years ago or 4 years ago. When I was aggregating, having to balance out a 300 and a 500 meg wireless link. Like that's a very common problem for a lot of guys. So guys, check them out. They're super cool guys. They have lots of fun, cool toys. And come to the show next time and say hi. Okay. So thank you very much.
Thank you. Appreciate it.
Yeah.
About equipment and methodology, so sit back and start learning. Lighting up the tower so people can start searching. Shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.